Welcome, folks. All right. Has it been a good conference so far? Have you learned a lot of stuff? Well, I'm going to teach you more stuff. That's my specialty, teaching stuff. But you know what? I'm going to do more than teach you stuff. I'm going to change your life a little bit this morning. How about that? I feel so strongly about NFC, near-field communication, that it is the future of networking, that I'm going to change your life just a little bit. If you've never seen this, you're going to see some stuff that I think will amaze you. And I think you're going to go away with ideas of how to incorporate NFC in your applications. If you don't, then I haven't done my job. If I don't get you a little bit excited about this. So I'm Jeff Procyse, and obviously I'll be your presenter. We're going to talk about NFC, near-field communication, in WinRT, which means in Windows 8 and in Windows Phone 8. They took part of WinRT from Windows 8 and ported it over to Windows Phone 8. This is one of the parts they ported, so the really cool thing is, once I learn how to do NFC on one of those devices, on one of those platforms, I know how to do it on the other as well. The code is basically identical. In fact, I'm going to be doing several demos for you using my Lumia 920, my Windows Phone 8 device, using this tablet right here, which unfortunately is not a Surface tablet because Surface tablets don't have NFC chips in them. This is one of the Samsung Build tablets that was given out a couple of years ago at Build. I use it quite a bit in doing NFC testing and prototyping because it has an NFC chip inside it. And at various times, I'm also going to be using NFC smart tags like the ones you see here. Now, even if you had never heard of NFC before you came to the conference this week, you've been using it all week. Every time you walk into one of these rooms to attend a presentation, when you touch your badge to that little board outside, there's an NFC chip, a passive NFC chip in your badge, which is rewritable, by the way, that records your presence here. Don't throw that badge away, because you can use it to do some of the things I'm going to do here, and it'll save you having to pay $10 or $15 to go out to Amazon.com and buy your own blank writable NFC tags. Your badge is a writable NFC tag, and I'll tell you the same thing I told the audience yesterday. If you intend to throw the badge away after the conference, please give it to me, because I can always use more NFC tags, okay? Now, the very first thing I want to bring to your attention before we start talking about NFC, what it is, how it works, what the WinRT NFC API looks like, is this right here. There's some folks back in Redmond, Washington in the U.S. who work in the Windows division. They're part of the Windows team, and they built the API that I'm about to show you. They had actually hoped to send a representative here, one of their program managers, so that she could talk with you folks after the session in the hallways, etc., get your feedback on how they implemented this API. Unfortunately, she was unable to make it, but what they have done is set up a link session, which any of you are welcome to join. What you want to do, if you're interested, is remember this time here, also this URL, which is a link URL. And if you want to talk to the team that built the stuff that I'm about to show you, to give them feedback, to ask them questions, to tell them what a great session I delivered or what a poor session I delivered, you are welcome to join into that link meeting. They would love to hear from you because they built this API. They did a ton of work. They haven't had a lot of opportunity to go out and find out how developers are using it and what developers like and don't like about this API. This is your chance to provide feedback directly to the Windows team. Now, with that said, let's talk about NFC. What is NFC? It is networking, wireless networking. It's also known as proximity networking because NFC networking is only good when two devices that support NFC are within proximate range of each other. Proximate range means typically 3 to 4 centimeters. I cannot use NFC directly to have a phone on that side of the room and a phone on this side of the room talk to each other. I can use NFC to establish a Bluetooth or Wi-Fi peer-to-peer connection between the two devices so that they can talk directly. But in terms of NFC itself, those devices have to be almost touching each other. Now, that doesn't limit us, as it turns out, because there's very fine support in this API for using an NFC tap, if you will, tapping two devices together to negotiate a Wi-Fi direct, or Bluetooth connection so the devices can then be pulled apart and can continue to communicate peer-to-peer. But that's just one of the things that NFC does for you. It is supported on a variety of platforms today, including Windows 8 and Windows Phone 8. Android supports it as well. The only notable operating system that is missing from the party is iOS. I thought about, just for fun, putting a slide in here titled NFC and iOS and then having a blank slide. But I thought, no, Apple's not here. It's not fair for me to take advantage of them like that. I'm certain that iOS at some point will finally come to support NFC, but for today, this is one of those things when someone asks you, what will your Windows phone do that an iPhone will not? NFC. And be sure to say it with a smile on your face. I don't know if it played here. There's a popular commercial in the U.S. It's an Android commercial. Played a few months ago, still playing some, I think. It opened up showing hundreds of people standing in line for an iPhone 5. And they were talking about all the great features of the iPhone 5. And then two gentlemen walk up outside the line, and they tap their Android phones together and transfer a picture from one to the other. And the Apple people waiting in that line look and say, "What did you just do?" And the gentleman says, "Well, I shared a picture with my friend." And then they tap again. He says, "Here, I want you to check out this playlist." Tap, and with NFC, they transferred a playlist from one Android phone to another. Well, by this time, the Apple folks are thinking, what am I really missing here? Why doesn't Apple give us this cool NFC stuff? It is NFC that allows you to transfer pictures from phone to phone on Android. Did you know that works on Windows Phone 8 as well? If someone else has a Lumia 920 here, you can tap your phone to mine. I can share a picture to you. You can share a picture back to me. In Windows Phone 8, they've done a wonderful job of integrating NFC into the OS by allowing us to share all sorts of content, not just pictures. The secret to it all is NFC, which is why when you buy a Windows Phone, you want to be sure to buy one that has an NFC chip in it. Not all of them have it. Now, let's talk a little bit about the high-level stuff before we start getting down in the weeds and talking details. Here are the primary use cases for which we employ NFC today. And if you haven't heard the term tap and do before, you're going to be hearing it a lot in this presentation, because tap and do is a term that Microsoft has come up with, which basically describes their interpretation and their implementation of NFC. Tap two phones together, share a picture. Tap your phone to a Bluetooth speaker set, establish a connection between the two over Bluetooth using NFC, pull your phone away, and then stream music out from the phone to those speakers. I actually saw a set of speakers that do that from JBL in an AT&T store recently. It was very, very, very cool. But here are the primary things, the three big things that we think of for NFC today. One is we use it to read smart tags. Now, that chip in your badge is a smart tag. It's a passive, unpowered tag, costs usually 50 cents or so, something like that, depending on where you buy it from. And when you held it up to that reader outside, using inductive power transfer, it actually applied power to this chip so that the reader could read the content of the chip. What I've done here is I've taken an ordinary business card and I've pasted something onto it called a Samsung TechTile. Samsung TechTile it's an NFC tag that you can buy from Amazon or a variety of other sources. You can use your Windows Phone to write data to that tag, your name, a URI, something like that. Then you can paste it on a business card, and if you hold it up to your phone, the phone, if it understands what's on that tag, will respond to it by launching IE or launching Skype or something like that. So one big use case for NFC is we label things with smart tags, be they conference badges, posters, maps of the train tracks at a train station, etc. And you hold your phone or tablet up to it, and information gets transferred from that smart tag to your phone or tablet so that it can show you more information about that. There's another big use case, and another one that I'm going to demonstrate, which is doing peer-to-peer communications with NFC. So in the first demo that I'm going to do this morning, I'm going to tap my phone and my tablet together, and we're going to transfer information between the two using NFC. A little bit after that, I'm going to go even further. I'm going to tap my phone and my tablet together, use NFC to negotiate a Bluetooth or Wi-Fi connection that will be exposed to my code on both ends as a simple socket, and then we will pull those devices apart and we'll let them to continue to communicate with each other peer-to-peer without having to go through a server or anything like that. If you wanted to build collaborative games so that everyone sitting in this room that has an NFC and Bluetooth equipped device could pair those things up and play those games together, it's easy to build that kind of thing using the WinRT API in Windows 8 and Windows Phone 8. Now there is a third primary use case for NFC today, card emulation mode. When a lot of people think about NFC, they think about making contactless payments. There are a few places in the world today that do support that, but to be honest, this is something that's out in the future. When you will store money on your phone, that's one of the reasons that Microsoft Wallet is built into Windows Phone 8. And when you go to the train station or the grocery store and you want to pay for something, instead of pulling out your debit card or pulling physical cash out of your pocket, you'll just tap your phone to a pay terminal and the data will be transferred. That will happen through NFC. I can't demonstrate that for you because it takes infrastructure that's not available yet. Special secure SIM cards and things like that. But in 5 years, I think most of us will be doing a lot of our commerce that way. Now, we're going to look at WinRT's NFC API. Before we do that, I want to say just a little bit about what's happening under the hood that will help you understand this API. NDEF stands for NFC Data Exchange Format. NFC standards are driven not by a standards committee like the W3C, but by a consortium of vendors called the NFC Forum. There was some information about them on the previous slide. Nokia, Samsung, and others are among the more than 160 companies that define these standards. One of the primary standards that they define is NDEF. It is the format of the messages that NFC-equipped devices use to exchange data with each other. Now, an NDEF message is just a little thing with a binary payload. NDEF has been designed to be very lightweight. It is a binary format, not a textual format. And the NFC Forum has defined several standard NDEF messages, but vendors and applications are free to define in-depth messages of their own. In fact, some of the things I show you in the WinRT API can only be used to have two Windows devices talking to each other because they're using application-specific in-depth messages. Some of the other demos I'm going to show you would work just as well with an Android phone rather than my Windows phone talking to this Windows 8 tablet because they are using standard in-depth messages. Now, these messages can come from a couple of sources. Number one, I can record an in-depth message on one of these smart tags, like the ones I pasted onto my business card. Then I can hold my phone up to it and allow the phone to read the in-depth message from that tag. Or an NFC-equipped device like my phone can emit in-depth messages of its own. So I can program my phone to squirt out an in-depth message. I can hold it up to my tablet, which is in-depth equipped also, and transfer that message between the two. This API, the WinRT NFC API, is agnostic to where the data is coming from. You just say, hey, I want to listen for messages. And that message can come from a smart tag, it can come from a phone, it can come from a tablet or anything else. Now, it may be interesting if you really like to know how things work, to go read the specs on the NFC data exchange format. You'll find that an in-depth message is a container for one or more records. There are a handful of standard records defined by the NFC Forum, but many more that different application vendors have defined themselves. But at the end of the day, NFC data exchange is about two devices exchanging in-depth messages, and device doesn't necessarily mean a powered device like a phone or a tablet. One of the devices in the equation could be an NFC smart tag like this one or the ones in your badge. With that, let's start talking details. How do you use this in your Windows and Windows Phone apps? If you look at how the team back in Redmond responsible for this implemented the API, they gave us a couple of classes that play a very central role in NFC-equipped apps that we build. Those classes are named Proximity Device and Peer Finder. You're going to see these used quite a lot in my slides and in my demos. Proximity Device is a class that represents an NFC-equipped device. There's a simple API for getting a reference to a proximity device. That API also tells you if your device is even equipped with an NFC chip. And the idea behind proximity device is it does a couple of things for us. One, it lets us register for events that fire when another proximate device enters our proximity. So if I wanted, I could use proximity device to learn when a tag like this one is held up to the phone and when that tag is taken away. Those events are called device arrived and device departed. Perhaps more importantly, the proximity device class contains methods for sending in-depth messages and for consuming in-depth messages from other devices, be it powered devices like a tablet or from a smart tag. So proximity device is the core of the WinRT NFC API. It is the starting point, and it's the first thing I'm going to use this morning to allow two devices to talk to each other and swap data back and forth. There's another class named PeerFinder that also plays a role in this. Now, PeerFinder ostensibly is how you, in a Windows 8 or Windows Phone 8 device, make contact with other Bluetooth devices. But there is some NFC intelligence built into it as well. If I want to be able to tap two devices together, connect them via NFC, and negotiate a socket connection over Bluetooth, Wi-Fi, or some other mechanism, the PeerFinder class makes it easy to do that. And I'll demonstrate that for you with these devices. So proximity device represents a proximity device, gives me methods for sending and receiving in-depth messages, as well as for detecting the arrival and departure of other NFC-equipped devices. PeerFinder allows me to use NFC to establish a connection between two devices that are tapped together so that I can continue to communicate over a more robust network connection. Now, before we look at code, you need to be aware that in a Windows 8 app or a Windows Phone 8 app, when you use the proximity APIs, you must indicate as much through the manifest. Now, the way you do this is a little bit different in the two different project types, but they're similar enough that you should recognize these dialogues here. On the left, I've opened up the application manifest for a Windows Store app, and I've gone into the capabilities page of the manifest, and I found the box labeled proximity, and I've checked it. If you fail to check that box, and then you try to call one of these proximity APIs in your Windows Store app, you will generate an access denied exception. I forget to do this sometimes. When I see the exception, I know, I need to go check that box in the manifest. On a Windows Phone 8 app, if you're going to use these APIs, you have to indicate that through the manifest as well. In Visual Studio, you open up that Windows Phone app's application manifest, go to its capabilities tab, and check the box labeled ID cap proximity. Once more, if you forget to do that, you will generate an exception the first time you call one of these proximity APIs, so don't forget to do it. We're going to start with the proximity device class, the core of the NFC API in WinRT. Remember that it represents a proximity device. And I told you it fires some events telling you about the arrival and departure of other devices, and also provides methods for sending and receiving messages. Let's look at some of those APIs before we put them to work on some actual devices. Number one, how do you find out whether the device that's running your code even supports NFC? If it doesn't have an NFC chip in it, then you won't be able to do anything with NFC. You call a static method named getDefault on the proximity device class. That's in the windows.networking.proximity namespace. And if that returns a non-null value, you now have a proximity device instance that you can call methods and register events on. If it returns null, then this device does not support NFC. Now, it's interesting, once you get a reference to a proximity device object, and that's what getDefault is returning, there's a little bit of information you can get about the device's NFC capabilities. You can get its device ID. That's actually the ID of the chip that's in that device. You can also get a value called bits per second, which specifies the maximum transfer rate for data in bits per second of the NFC chip in this device. And you can read a value called max message bytes that tells you the maximum size of an in-depth message that you can write out in one gulp from this device. Now, generally, that's something so large with a typical chip, it's 10 or 20K. You don't worry about it because over NFC, you'll be exchanging very small messages. If you want to use NFC to transfer larger amounts of data. Rather than use NFC directly, you'll use it to establish a Wi-Fi or Bluetooth connection through which you can transfer unlimited amounts of data. Now, the proximity device class fires a couple of events named device arrived and device departed. Again, if I were to execute this code on this slide on my Windows phone, then when I took this NFC tag and held it up to the NFC chip in my phone, I would see a device arrived event fire. Then, if I take that smart tag away, when it gets a couple of centimeters away, I'll see a device departed event fire. Now, why is that useful? I'm going to show you examples of apps that register to receive NFC messages. You could build the app so that the moment the app starts, it's constantly listening in the background for NFC messages. Or you could be a little bit smarter about it, and you could wait until a device arrived event fires to tell the system that you want to listen for NFC messages on a mobile device. That might conserve a little bit of battery power. Publish message is one of three methods in the proximity device class that you can use to send in-depth messages to other devices. Now, this method is kind of interesting. The message that it writes out is something that's specific to Windows 8 and Windows Phone 8. While you could write Android code, for example, to read and interpret that message, you would have to reverse engineer what Microsoft is doing. This method is intended primarily to communicate with other Windows devices. Unlike some of the other methods in this proximity device class, this method cannot be used to write data to a smart tag. It is only for writing to other devices and to other Windows devices in particular. Now, let me show you how it's used. So, I'm some code. Maybe I'm executing on a Windows phone with an NFC chip. And I want to publish an in-depth message to any device that enters my proximity and might care to consume that message. So I call publish message on that proximity device object that I received when I called get default. And I pass in at least two parameters. The first is a string, which is the message type. In this API, the message type has to be Windows.something. It doesn't matter what the something is, but it has to be Windows.something. As you'll see in a moment, if another device wants to receive this message, it will have to register to receive Windows.something messages of its own. What this allows us to do is publish multiple messages of different types intended for different consumers at the same time from a device. Now, if you pass that message only, or that method only two parameters as I'm doing, you won't know if anyone has actually received the message. But you can provide a third parameter, a callback method, which I've called onMessageTransmitted, that will tell you if that message has actually been delivered to someone. If you want, in that callback, you can call a method named stopPublishingMessage. Now, let me explain what's going on here and why that is sometimes important. When you call publish message, that does not just publish a message until it's consumed by another device. Until you call stop publishing message, that device will continue publishing that message. So I could call publish message, hold a device up, get the message, pick up another device, hold it up, it would get the message too. If you only want to transfer this to one recipient, then you'll want to use this message transmitted handler as I'm doing and call stop publishing message when you get the notification that the message has been delivered. The other side of the equation, as long as we're using publish message to talk to different devices, is how a device can receive a message from another Windows device. That's why proximity device gives us a method named subscribe for message. Now, as you're going to see later, this method isn't just for subscribing to these Windows-specific messages. It is much more general purpose. You can use it to subscribe to any in-depth message. In fact, I'll use another form of that if I want to consume the data that's on a smart tag like this one on my business card. Subscribe for message says to the system, if a message of the specified type enters my proximity, I want to be notified. And the way I use the method is quite simple. I get a reference to that proximity device by calling proximity device.getDefault. I call subscribe for message. I specify in the first parameter the message type. Again, if I'm going to consume a message published by publish message, the message type has to be Windows dot followed by whatever name you want to give it. In other words, the sender and the receiver, in order to exchange messages this way, have to agree on the name of the message or the message type. And then in the second parameter, you provide a callback method, which will be called if another device, another proximate device, enters your vicinity and is publishing a message of the type that you've subscribed for. Now, as with publish message, that message continues to be published from a device until you explicitly call stop publishing message. Similarly, when you call subscribe for message, you will continue receiving those messages each time a proximity device publishing that message enters your vicinity until you call stop subscribing for message. So if you want to get that message one time and not be bothered with it again, you might do as I'm doing here and stop subscribing for the message inside the handler that's called when the message is received. Now, I think all of that would probably make a lot more sense if you saw some code. So, I'm going to show you a demo first, and then if it works, we're going to look at the code in Visual Studio. If it doesn't work, we'll look at the code as well. Now, this is where this gets a little bit dicey because a lot of times when you attend presentations on NFC, what the presenter has done is installed a couple of VMs, and in that VM, he or she has installed the Windows 8 device driver kit with a proximity device driver. So they're simulating messaging between devices using two VMs. Personally, I don't think that makes for very compelling demos. So I'm going to take a risk, and I'm going to do it with real devices. Now, the problem is I don't have cameras on these devices, so I'm just going to have to hold them up so you can see what's going on. But we're going to try this. And let me warn you up front, they don't always work. 9 times out of 10, these demos work. Every now and then, they just don't work. Sometimes I have to reboot one of the devices to get it to work. But you know what? You're all good folks. You're all here today. I think, fingers crossed, these demos are going to work perfectly first time, every time, huh? So here's what we're going to try. I want to start with my Windows Phone. And by the way, all these samples I'm going to show you, I've zipped them up, posted them on SkyDrive. At the end of the session, if you'll help me remember, I'll give you a URL so you can download all of these samples yourself and play with them or do with them what you will. I'm going to pull up my Windows Phone, and I'm going to run a little app here. Let me get it going, then I'll show it to you. And by the way, if any of you in the back want to move down so you can see these devices I'm holding up and hear what's going on, you'll hear little bells ringing and stuff like that, feel free to move down. But this one shows a grid of rectangles. This is a Windows Phone adaptation of the Game of Life from the October 1970 issue of Scientific American magazine. If you're familiar with that game, it allows you to draw grids of cells, which I'm doing with my finger here. You'll notice some of those rectangles are now lit up. And then you can run a cellular automata simulation, evolving these cells from one generation to the next, using some genetic algorithms to determine which cells survive to the next generation, which ones do not, and which ones are born into the next generation. So in this phone app, I just tapped it here. By the way, this app is in the Windows Phone store without the NFC support. I published this in the store a long time ago. You can see the simulation running. The little squares are dancing around, okay? So I'm going to stop that simulation. And I'm going to draw something in here, just kind of draw a random pattern of cells that looks kind of like a bird with his head to one side. That was purely coincidental, by the way. Now, I'm going to set this up here for a moment and go over to my Samsung Build tablet. Again, I'm using this rather than a Surface tablet because neither the Surface RT nor the Surface Pro, unfortunately, has an NFC chip in it, but the old Samsung Build tablet does. And it just so happens I have a version of this app running on this tablet as well. Let me log in since it had timed out on me. And let me fire that app up on this tablet. And I'll turn it up here. Now, it's a little bit harder to see, but you should see the same grid of cells that you saw on my phone just a moment ago. They're kind of dark right now because they're not lit up. But what I'm going to do, hopefully I can do this without dropping the tablet, is trace some patterns in there. And then if I want the simulation to run, I'll press the Run button. And now those rectangles are dancing around. We're evolving from one generation to the next there. And now I'll stop the simulation. And let's clear it out. Now here's why I'm showing you this. I built NFC support into both of these. Suppose here on my phone, I'm playing with this and I found a really cool pattern. Do you realize doctoral dissertations have been built around the game of life, around these patterns, and around patterns that do special things like replicate themselves? So I found a really cool pattern here, and I want to share with a friend. So I'm going to tap a button here that I put in the toolbar that calls Publish Message. I'm now publishing an in-depth message, a Windows-specific one, containing this grid of cells right here to any device, any proximate device that approaches me and is interested in getting the data. Now, on a tablet like this, you have to know exactly where the NFC chip is because it is proximity networking. On a Samsung build tablet, the chip is about right here. I'm going to tap the two devices together. Now remember, I'm looking at a blank grid here in the tablet. I'll tap the two devices together. Let me try it again there. Because did you hear the little dinging? Could you hear that? That was my phone telling me that another proximate device had entered. I told you it doesn't always work. Worked last night in my hotel. We're going to try it again. Sometimes I have to reboot the tablet. I'll draw another pattern on here. This time it looks just like a big blob. I'll press the button to call Publish Message and start publishing an in-depth message. By the way, when this app starts up, it calls Subscribe for Message. It's listening for the same message, and I'll try one more time. And look at that. It worked that time. Yeah. Hey, second time's a charm, right? So I now have the same pattern on both of these devices via NFC. Now, this is not exactly how we transfer pictures from phone to phone, because pictures can be large and in-depth messages are small. We use a socket connection over Bluetooth or Wi-Fi to transfer pictures. But when it comes to publishing or transferring small amounts of data between devices, there was a total of about 300 bytes of data that I transferred over. When it comes to transferring small amounts of data, this tap and do that you just saw, or tap and acquire content, is perfect. And you can see that it worked pretty well, at least the second time. Now let me show you what the code looked like to make that work. You like that, by the way? Is that cool? Didn't I told you I was going to change your life a little bit today, right? Wait till you see the demos that come after this. This is just the warm-up, folks. Let's take a quick look at the code that was required to make this work. So we'll go into Visual Studio, and I'm going to open up a project named NFC Content Sharing Demo. And by the way, if you want to go ahead and write down the URL where you can download the source code from, I'll put that up there right now. It's a SkyDrive link. It is case sensitive, by the way, at least those last 6 digits. You'll find a zip file there containing all the demos I'm going to show and probably a couple that I won't show. Feel free to do whatever you want with that sample code. Share it with your colleagues. Do whatever you want. Since I wrote it, it's not guaranteed to be bug-free, so user beware, okay? All right, I'll pull that back down and I'll put it back up again at the end of the presentation. So let's take a quick look at the code here. So in this solution, there are 2 projects. One is a Windows Phone 8 project named NFC Content Send Demo. And I want to scroll down here to a little method named onShare. When I drew some cells into the grid and I tapped the Share button in the application bar, this is the event handler that executed. Now, before I show you this, let me show you what I did when the app started up. At startup, I checked to see if this device features NFC support by calling proximitydevice.getDefault and checking for null. Now, I could have popped a message up to the user if I found there was no NFC support. I chose not to because this app obviously works standalone. Running it on an NFC-equipped device is just a bonus. Then I store away a reference to that proximity device object, the one returned by getDefault. And when the user taps the Share button, here's what I do. I first check to make sure that, yes, we do have NFC support on here. And what I'm basically doing here is serializing out the current state of the game. What I'm doing is building a string of 1s and 0s. Each 1 and each 0 represents the current state of one of those cells in the grid. Now, you may wonder, why am I stringifying this. When you use that publish message method, you can only transfer strings. It's not for binary data. I'm going to introduce in a few moments a method named publish binary message that would allow me to do a binary transfer. But in this case, because it's so easy to transfer messages between these devices using publish message, and publish message accepts only strings, I chose to use a string also. Then here's the call to publish message. I named the message windows.life, and then I wanted to, you'll notice that I'm disabling that app bar button, the share button, when the user presses it. What I'm doing here is registering to be notified if the message has been transmitted to another device, and I take that opportunity to stop publishing the message. If I want to share this with a second device, I'll have to tap that button again, and I re-enable the share button in the application bar. Now take a look at this right here. And this is something that was not in the slides, but something that you need to take note of. When events fire, when these proximate events fire telling you a message is transmitted, a message has arrived or something, those events fire on background threads, or those callbacks come on background threads. If you want to do something to update the UI, like enable or disable a button, you must marshal back to the UI thread first. In a Windows Phone app, you still that using dispatcher.begin-invoke. In a Windows 8 app, you typically use dispatcher.run-async instead. So here's the code in the phone that publishes that message and makes the state of the game available to another application. By the way, this would have worked just as well if I'd done it with two phone apps. I just used a phone and a tablet because I don't happen to have two phones with me. Now, the other half of the equation is the Windows Store app, the one running on the tablet that received the data. Take a look at what it does when it starts up. Yes? Okay, yeah, so that text message, whose type I called windows.life, is there a limit on how long it can be? Technically, no. But there are two things that practically limit it. Number one, every NFC chip has a maximum number of bytes it will transfer in one message. And remember, you can get that from the proximity device's max message size property. The other thing is, when you're transferring data this way, I'm not doing this over Bluetooth or Wi-Fi. I can only transfer while those devices are touching or almost touching. If you try to transfer megabytes worth of data there, the user's not going to like it very much, having to keep those things in contact until you're done. There's a better strategy for doing that, which I'm going to show you next. But technically, no, there's not a limit, other than the limit imposed on you by the NFC chip in that device as to how long the message can be. And by the way, for most NFC chips, that's 10 to 20K. So my 250, 300 bytes I was transferring was well under the limit. Here's the code for the Windows Store app that received the data. When it starts up, I also check to see if there is NFC support in this device. And if there is, I subscribe for Windows.life messages. Remember, this is the same message type that I used in the phone app. So if another device enters my tablet's proximity that is publishing a Windows.life message, my onMessage received event handler fires. Now remember, this will fire on a background thread. So if I want to do something with the UI, like take that string that has been transmitted to me and light up some of the cells in the grid, I must marshal back to the UI thread. This is how we do that in Windows 8. And all I'm doing here is taking that string, which I get from the data as string property of the proximity message object reference passed to me here. Where is it? There we are. I read the data as string property. I get the string that was transmitted to me. And here's just some grungy code to apply that to the cells in the grid. You take away the grungy code, the actual data that transferred the message and that received the message, 5 or 6 lines of code. NFC data transfers right there. Now imagine this. No matter what kind of app you're building, for a phone, a Windows Store app, imagine how useful it would be in a lot of cases for someone to be able to tap two devices together and transfer the entire state of that app over. You could transfer contact list, playlist, anything, any data that's relatively low in volume that you might want to share with another device, another user. This is perfect for that. Okay? Do you like what you see so far? Would you like to see it get better? All right, let me show you the next step on the road to NFC bliss. The demo that I just showed you was all fine and good, But it very much relied on the fact that the amount of data that I was transferring between the two devices was relatively small. In fact, they transferred in the blink of an eye. So all I really had to do was touch them. I could immediately pull them away. The data had already been transferred. But what if I wanted to do something like you see in those Android commercials, or something that the Windows Phone can inherently do, and transfer pictures between devices? Well, I probably don't want a user to have to hold those two devices together for 5 or 10 minutes while a 20 or 30 megabyte piece of data transfers. By the way, when you transfer data directly through NFC, I should have mentioned this earlier, it is a relatively low bandwidth networking medium. The theoretical maximum data transfer rate is about 400 kbps. In practice, it's actually substantially less than that. So even if you did say, okay, I don't care about my users, let them hold the devices together for 10 minutes. It might be an hour to transfer a 20 megabyte photo because of the relatively low bandwidth of an NFC connection. But what about this? What if we could use NFC to negotiate a network connection? That's not only possible with NFC, but the Peer Finder class in WinRT makes it very, very easy to do. The idea here is that we tap the devices together, and we don't immediately transfer an in-depth message, at least not one that we see. Instead, we allow the operating systems on the two devices to negotiate a connection that will then allow the devices to be pulled away. That connection shows up to us as a stream socket, so it's just sockets programming. And the connection can travel over Wi-Fi, Wi-Fi Direct if both devices are equipped with Wi-Fi Direct support, or Bluetooth. I'll show you later how to tell Windows and Windows Phone if you have a preference. Maybe you prefer Wi-Fi over Bluetooth, or you prefer Bluetooth over Wi-Fi, or you have no preference. You can actually tell it what your preferences are. It's interesting, once the connection is established, there's not an API for finding out, am I talking over Bluetooth or Wi-Fi or whatever, but you don't really care because you have a higher bandwidth connection. Here's how you use the Peer Finder class to tap two devices together, establish a socket connection between the two so that they can continue to communicate even when they are pulled apart. First, you check the Peer Finder class, you check with its static supported discovery types property, and you look for a bit flag whose name is peerDiscoveryTypes.triggered. If that bit flag is present, that means that tap and connect scenarios are supported on this device. In other words, we can tap it to another device and establish a network connection with it. Obviously, if that bit flag is not there, then you're going to have to find some other way to connect the devices. There are Bluetooth APIs in Peer Finder for searching for Bluetooth devices in your proximity, but remember, we're talking NFC here. We want to tap the devices together because discovery doesn't get easier than that. If I determine that the device I'm running on does indeed support tap and connect, then the next step is to register a handler for a special event named Triggered Connection State Changed. This is the event that will fire when another device that supports this type of discovery is tapped against your device. In fact, it fires not just once, but several times. I'll say more about that on the next slide. You register a handler for the event, and then you call Peer Finder's static start method. Basically, the device is now listening. So if another NFC-equipped device is tapped to it, and it supports the protocol that allows the stream socket connection to be negotiated, well, that connection will just be handed to you on a silver platter. Notice what I'm doing in my triggered connection state changed event handler. If I see that the state property of the event args is triggered connect state.completed, then that tells me that these two devices have been connected together, not by NFC, but with a network connection. And from the socket property of the event args, I can get a reference to a WinRT stream socket object, which I can do with whatever I care to do. By the way, it's not a bad idea at that point to call peerfinder.stop, because now that you're connected to another device, you probably don't want to continue advertising and try to connect to others as well. Now, that triggered connection state changed event is kind of an interesting one. It will fire several times when another approximate device comes close to you. For example, when the peer found event fires, that means another device that supports tap and connect is in your proximity, and the two devices, while not quite fully connected, are in the process of establishing a network connection. If you want to provide some feedback to the user, you could actually say to the user, it's okay to pull the devices apart now, because once that peer found value comes to you, the system has everything that it needs to finish establishing that network connection. The one we typically really care about is the completed value, because that's the one that hands us a reference to a stream socket. Now I'm going to demo this for you in just a moment, but before I do, I want to show you a couple more things about this API that can be useful. By default, when you use this mechanism I just showed you, the trigger connection state changed event on PeerFinder, the network connection that's established between these two NFC-connected devices can be a Bluetooth connection, a Wi-Fi connection, or a Wi-Fi direct connection. If you've never heard of Wi-Fi direct, it's relatively new. Not many devices support it yet. It takes a special chip to do it, but it allows two devices to connect to each other and communicate via Wi-Fi without a router in between them. Effectively, the devices become their own routers. Now, if you care which of these is used, maybe you only want a Wi-Fi connection because it provides higher bandwidth than Bluetooth, you can set the allow Bluetooth property of the PeerFinder class to false, and now Windows won't even attempt to create a Bluetooth connection between the devices. All of these values default to true, and by the way, as the comment indicates, Wi-Fi Direct is not supported on Windows Phone, at least not yet. It is supported on Windows 8 if the device that's hosting the code has a device that supports Wi-Fi Direct. Now, it's kind of interesting. As I said earlier, if you leave all of these properties set to true, then you don't really know what type of connection has been established once it is established, and there's no API for finding out. All you can do is control up front. You can prevent Windows from attempting to use certain of these networking mediums. What Windows does under the hood is kind of interesting. Does it prefer one type of connection over another? No, it doesn't. What Windows does is it attempts to establish a connection over all three of these, and the connection that comes back first is the one that it uses for that socket connection. That will typically be Bluetooth, but it won't always be Bluetooth. It could be Wi-Fi direct in some cases. Now, before I do the next demo for you, there's something else really important that you have to know about PeerFinder. I can use these APIs that I just showed you to connect two Windows phones together. They will work without modification. To tap them together, establish a network connection so they can talk to each other. Or I could use these APIs, just as I've showed them to you, to do the same with two Windows 8 devices, say two Windows tablets. But there's a little bit of additional work that you have to do if you want to connect a Windows Phone device to a Windows 8 device. And this same mechanism, although this is not documented, by the way, this same mechanism can be used to connect to other types of devices like Android devices, okay? Let me show you what extra you have to do to connect two operating systems that are not identical. Let's say you're writing a Windows Phone app. It's going to support Tap to Connect. You want to be able to connect to the same app running on another Windows Phone, but you would also like to be able to connect to a related app running on a Windows 8 device. What you have to do is use PeerFinder's alternate identities property, which is basically a dictionary, and provide the alternate identity of the app on the other platform. Now, if you're a Windows Phone app, the alternate identity for a Windows 8 app on another device is a string that is the package family name of that Windows 8 app, which you can get from the project manifest with some special characters appended at the end, an exclamation mark followed by APPP in the exact case that you see right here. On the other hand, if you're a Windows 8 app and you want to be able to use PeerFinder to tap and connect and establish a network connection to Windows Phone apps, then you have to provide the alternate identity of your app on a Windows Phone. The syntax is slightly different. You don't have to append that Bang app, but once more, you go to the application manifest for that Windows Phone app, you get the app ID, and you provide it in PeerFinder's alternate identities. Remember, if you don't do this, you can connect Windows phones to Windows phones or Windows 8 devices to Windows 8 devices, but you cannot connect a phone to a Windows 8 tablet without doing this. Fortunately, it's a couple of lines of code. Now, we are going to see if this next demo works. And Katrine, at risk of embarrassing you, I could use an extra set of hands on this one. Could I get you to help me out? Okay. Hope I'm not embarrassing you. You've been up here many, many times before. So what we're going to do is start a couple of apps on these devices here. So I'm first going to get this up and running on the tablet. And we'll shut that down, and let's see here. The app I want is Windows Scribble. Okay, and if you'll just hold that up so everyone can see it. In fact, let's hold it like that if you would. You can't see that in the back. There's a big white rectangle. I'm an expert at drawing rectangles in XAML. I can do it all day long. And there's a little blue message on it that says Tap to Connect. That app is actually listening right now. I've called PeerFinder.start after registering a handler for trigger connection state changes event. It's listening for another device to be tapped to it. So I've built a companion app for it on the Windows Phone. Let me get that up and going as well. And when I start it, it also shows me a white screen with a message that says Tap to Connect. Now what we're going to do, you and I are going to tap these two devices together. And we're going to establish either a Wi-Fi or most likely a Bluetooth connection between the two, and we're going to talk to each other, okay? Now, I got to remember where that chip is. It should be right down here somewhere. Okay, we're connected. In fact, you notice the message is gone. Momentarily, there was a message that said peer found. Same thing on my phone, but the messages have gone away. We're connected probably by Bluetooth, so I'm going to send you a message. And do you see what I did? Yeah, do you want to reply? You can scribble on there too. No dirty words now. Just underline the message or something. I realize it's hard to see on the phone. Tech? Yes, high tech. Very good. So we could play tic-tac-toe or anything else with this, right? How about that, folks? We establish a connection through NFC Tap and Connect. They're talking probably through Bluetooth. So as long as these things are within Bluetooth range, we can communicate back and forth all day. Is that cool? All right, thank you. Very, very useful to have that extra set of hands. I don't think I could have done it without you. So would you like to see the code that it took to do that? It's a little bit more involved, but not too involved. In fact, not too involved at all. So let's open up a separate project here. This too is part of that zip file whose URL I gave you. Let's see, I don't want that one. I want to go into my NFC folder and open NFC Scribble demo. Now, like the first demo that I showed you, there are two projects inside this one. One is a Windows 8 project. The other is a Windows Phone 8 project. And the one named Phone Scribble is the phone project. Let's first take a look in here. And the cool thing about this is the code is virtually identical in both because it's just WinRT, folks. So let's go to scroll down in here. And when this thing starts up, this is the phone app, remember. I first make sure that the device I'm running on supports Tap and Connect by checking supported discovery types for the peer-discovery-types.triggered flag. And if I find that they're not, then I display a message to the user saying, sorry, you can't run this app. You can't tap to connect on this device. But if it is supported, then I register a handler for that triggered connection state changed event, and I call PeerFinder.start to start listening for other devices to tap up against me. But remember, in this example you just saw, we had a Windows 8 app talking to a Windows Phone 8 app, and that doesn't happen by default. You have to write an extra line of code to make that happen, specifying on this phone app here the alternate identity of that app on a Windows 8 device. So what I did is I went into the manifest for the application that Katrin was running on the tablet. I got the package family name and pasted it in right here and appended that bang app at the end. Then, once we tap those two devices together, the trigger connection state changed event fired. Here you see me when the peers are first found. Briefly, a peer found message appeared on the screen of each device. Very, very briefly, there was a connecting message that appeared. But what's really important is once that event fires telling me the network connection has been established, then right here, I get a stream socket object. And most of the rest of this code, in fact, virtually all the rest of the code in here is just boilerplate a socket code shooting messages back and forth with all the XY coordinate pairs that each of us is sketching on that device. Now, the interesting thing right here is if you look in the Windows Store app, it's virtually the same code. Take a look. Here's the Windows Store app. It too, when it starts up, in fact, this code is identical, checks to see if tap and connect is supported, and if so, it registers an alternate identity. The only difference is I'm specifying I do want to be able to connect to like apps running on the Windows Phone. I went into the app manifest for the phone app, got the app ID out, pasted it in right here into the Windows Store app, and everything else is exactly the same. One of the benefits of having a shared API, to the extent you rely on WinRT APIs in Windows 8 and Windows Phone 8, you can pretty much just cut and paste the code back and forth. Pretty cool stuff. I won't go through the socket code. It is just socket stuff. But what I really want you to take away from this is not only can you use NFC to communicate between devices by exchanging short, in-depth messages, you can use NFC to connect two devices via Bluetooth or Wi-Fi so that they may continue to communicate when the devices are pulled apart. That is cool stuff right there. But that's not all. You want to see more? Or should we just stop right now? Now we've got it. Why don't I show you some more, huh? And Katrin, I may need you to go to The Hague with me, because otherwise I'm going to have to pull someone out of the audience to do that same demo for me. It works so well, I'm not even going to try to do it on my own anymore. Let's go back to the slides here. Now, I want to introduce you to another method of the proximity device class, one named publish binary message. Now, remember I told you early on that there are three methods you can call to publish a message in proximity device. One of them you've seen, publish message. It lets you transmit string data between Windows devices. Publish binary message, as the name implies, lets you publish binary data. And while you can use it to transfer binary data between devices, in the real world, it's hardly ever used that way. There are other reasons that this method is one of the most important parts of the NFC API in WinRT. Let me give you an example. Suppose, for example, you wanted to write some data to an NFC tag like this one right here. This is how, by the way, if you want to take your badge and you want to write over it, the data on it, NFC data of your own, this is how you'll do it. This is a neat little trick here. It might make a good interview question. How do you find out when a smart tag approaches your device how much data the smart tag can store? Now, there are lots of different types and brands of these smart tags. Most of them are very, very restricted in how much data they can store. These Samsung Tech Tiles, which I pay a couple of bucks a piece for from Amazon.com, can hold about 1K of data. Many NFC smart tags are limited to just 80, 90, 100 bytes. It might be useful before you try to write something to a smart tag like this to know what its capacity is. This is how you get the data. You actually subscribe for a message called writable tag. And now, when a writable smart tag enters your vicinity, then you'll get this callback, which I've called onReceived, and from message.data, that tells you what the writable capacity of that tag is in bytes. Of course, the reason you might want to do that is, how do you write things to smart tags? Now, I think to write the information to the NFC chips in your conference badges, they used a separate device, a USB device that plugs into a computer. You don't have to buy one of those. You know how I write smart tags? with my Windows Phone. Every smart tag I'm going to show you the next few minutes was written out by this phone right here. That's a cool thing about an NFC device like this. It not only reads NFC data, it writes NFC data as well. And this is how you write data to a smart tag. You use publish binary message, and the key is that first parameter, Windows URI : write tag. What I'm doing here is writing a URI. A URL of a website, for example. And even though the syntax is Windows URI, this is generic. The URI that you write to this tag will launch that URI on any NFC-equipped device, be it an Android device, a BlackBerry device, a Windows device, or what have you. In fact, let me just show you something real quick. This isn't part of the demos, but I happen to have one of these right here. So I'm going to fire up my Windows Phone. And I don't have to run an app. One of the things a Windows Phone does by default, and Windows 8 does to some extent, but to a lesser extent, is it automatically recognizes when an NFC device approaches it and offers it a URI. Well, I've used my phone to write a URI of a website onto the Samsung Tactile that I stuck onto the back of the business card. So when I hold this up to my phone, it just buzzed at me. And I've got a little message that says, receive content. This is Windows Phone saying, somebody just offered me a URL through NFC. Do you want to accept it? I'll say yes. It's going to launch Internet Explorer and show me that website right there. So you could do this on your business cards. You could put one of these, $2 sticky tags in the back, write the URL of your website or your resume or whatever. Now, when you hand your business card out to someone, they can hold it up to their phone and go straight to your website and see whatever it is they want, that you want them to see about you. This is the code that I used to write that URI. Very, very simple. Here's something even cooler, though. There's lots more you can write to an NFC tag besides just arbitrary information like your name as a conference attendee or even a URI. You can write special tags to these smart tags called launch tags. Now, these are app-specific. I'm going to show you how to write data to an NFC smart tag that will launch a Windows app or a Windows Phone app. And a little bit later, I'm going to show you how to modify that code to launch an app on an Android device as well. Unfortunately, the NFC Forum has not defined standard launch tags for different operating systems, but different vendors like Microsoft and Google have come up with their own and have documented them well enough that we can, on any device, we can write out launch tags to launch apps on other devices. If I want to write to one of these guys right here, a tag that will launch a Windows 8 app on a device like this tablet, and even pass parameters into it, here is the code that I use. And the key here is that argument string, which I've italicized, that can be anything you want. That way you can launch the app in a known state because it can consume that data when it launches. That second string, Windows, that identifies the platform. That's short for Windows 8. And that third string is the ID of the application that this would launch. This would be something that you typically get from the package family name in the manifest. Just for fun, I went out and got the app ID for Angry Bird Space from the Windows Store so that I could, if I wrote this out to a tag, I could launch Angry Bird Space from a smart tag like this. Now, the syntax is slightly different if you want to write out to a smart tag data that will automatically launch a Windows Phone app and pass in a parameter. Notice I've changed the platform string, also changed the ID to that of a Windows Phone app. But here's the cool thing. This is not documented very well, but it actually works, and I'm going to demonstrate it for you. You can write to an NFC smart tag a special in-depth message that will launch either a Windows 8 app or a Windows Phone app. I call this a dual launch tag. The parameter that you pass in, the argument, has to be the same for both platforms, but you can allow a Windows Phone or Windows 8 app to be launched from one of those smart tags this way. Now, I'm going to demonstrate this for you, but let me show you this also. If you're going to let your app be launched from NFC like this, you'll need to know how to consume that argument parameter that you wrote to the tag. It's slightly different in Windows 8 and Windows Phone, but it's very similar. In Windows 8, this is how you consume that parameter. In fact, there's not a lot of code that you have to write. If you have already built in code into your Windows 8 app to support launching from secondary tiles, The exact same code works for NFC as well. You literally don't have to add a single line. Basically, you take a look when your page is activated. You take a look and see if parameter is non-null. Because of code that was put into app.xaml.cs by Visual Studio when it created the project, when the app is launched, any parameter passed in from a secondary tile or an NFC smart tag will be passed to the page that's activated in the parameter property of the event args. On a Windows Phone, it's similar but slightly different. What will happen on a Windows Phone is when the default page of the application is activated, you will have a special query string whose name is ms_nfp_launch_args. So in onNavigated2, you'll consume that query string the same way you would any query string passed to any page in the Windows Phone. So little to no code change is required in Windows 8, minor code change is required in Windows Phone 8, and we can automatically launch these apps and consume launch arguments passed into them. So we're going to try this. So I've got a smart tag here to which I have written a dual launch tag. I've got a weather app on my phone and on the tablet. They're two different apps, obviously, for two different platforms, but they're similar. They look pretty much the same on the outside. I should be able to hold this up to either one of those devices and automatically launch the app. And what this app does, it lets you input a U.S. zip code, a U.S. postal code. It goes out and gets the current weather at that location in the U.S. and shows the current temperature in degrees Fahrenheit. I encoded the zip code as a launch argument on this tag. So not only should this be able to launch the app on both of my devices, both of them should come up automatically showing the zip code for the town that I live in and the current temperature at that zip code. Let's try it first on a phone to see if it works. So, obviously, I've already installed this app here. By the way, it's kind of cool. What would happen if I'd put a launch tag for a Windows Phone app on this tag, and then I held it up to a phone that didn't already have the app installed? Windows Phone then directs you to the Windows Store to go download that app. So there's a good user experience even if the app is not pre-installed. So let's try it. I'm going to hold it up. I get a message from my phone saying, open app, someone wants to use phone weather demo with you. I'll tap the button that says open app. And it looks like in Concord, Tennessee, which is a little suburb of Knoxville, Tennessee, near the Great Smoky Mountains National Park, it is currently 33 degrees Fahrenheit, making me feel really glad that I'm right here now and not back home. Although when I get home this weekend, it's supposed to be up near 70 degrees. So that's how I try to plan my travel. I miss the cold weather back home, hit the good weather here, and then get home in time for the good weather. So we launched an app. It does show the zip code 37934 at the top. So clearly we consumed that launch parameter. But let's try the same thing on this tablet right here. I've installed a Windows 8 version of this app on this tablet. Whoops, and I pressed the wrong button there. In fact, I've got the entire tablet upside down. There we go. See if it'll, there we go. Let's log back in. Your handwriting is better than mine, by the way. And let's get this app launched. Oh, actually, I don't have to launch anything because a Windows tablet's always listening for an NFC tag to come close to it. I should just be able to do this. I should just be able to do this. And it worked the second time. There's a little toast window at the top of the screen that says Start an App, tap to start Contoso Weather. And here's that same app running on a Windows 8 device, again showing that it's 33 degrees back in the part of Tennessee that I live in. Dual launch tag, zip code parameter passed in. The apps, obviously, I had installed on here. Each app, when launched from this tag, consumes the launch parameter and adjusts its state accordingly. Pretty cool stuff, huh? Yes, sir. Where do you get the app ID? Out of the application manifest if you own the app. But like if it's, let me click this back. You're wondering, where did I get Angry Birds app ID, right? I did something I'm not supposed to do. I went into my box as an admin and looked in the hidden directory where Windows Store apps are installed, found Angry Birds, and manually copied the app ID out. Now, what I did in this case, since I wrote both of these apps, I got the app ID directly from the manifest in Visual Studio. okay? We're almost done. We have 5 minutes left, and that's pretty good. Let me mention this to you. I think it's very, very cool what the Windows team has done in building these NFC APIs. What they've essentially done is taken the most common use cases where we want, for example, to connect two devices together and exchange short in-depth messages, or connect them together with a network connection so we can shoot larger amounts of data back and forth. And they've made it very, very easy to implement those scenarios. But there is more. They did not, purposely, by the way, try to provide wrappers around all the different standard in-depth message types, or provide wrappers around some of the popular application-specific message types like Android launch tags. There is a library that may interest you. It's free and it's open source. It's called the In-Depth Library for Proximity APIs. What it allows you to do, if you want to, is build applications that handle any kind of in-depth message or write out any kind of in-depth message, not just the ones for the scenarios that the WinRT API has anticipated. For example, when you read about NFC, you often read about smart tags, or smart posters, rather. The idea is that you encode data on a chip that's embedded in a poster in a railway station or something. The user can hold their phone up to it and get information from that smart poster. Not just a URL, but perhaps textual information and other things as well. There is no direct support in WinRT for writing a smart poster tag out, even though this is one of the in-depth message types that has been standardized by the NFC Forum. But this in-depth library for proximity APIs contains a type called in-depth SP record. SP stands for smart poster, which makes it very easy to write smart posters out to NFC tags or to read smart posters. And here's another use for this. Suppose I did want to write to one of these guys right here a tag that would launch an Android app on an Android device. Well, the Windows API for NFC doesn't provide a wrapper around that, but the in-depth library for proximity APIs does. This simple little bit of code right here will write an Android launch record to a tag like this one. In fact, I could prove that if I had an Android phone with me, which I don't. For some reason, I don't like Android phones. Don't know why, but I don't. I could hold this up, and we could launch an app from there as well. So I'm not going to do this demo because it's not very exciting anyway, and we're almost out of time. We have about 4 minutes left. I would like to conclude with this. I told you up front that there are 3 methods for publishing messages in the proximity device class. You've seen 2 of them. I showed you publish message. We used it to transfer the state of a game back and forth between 2 devices. I also showed you publish binary message, which can be used to transmit binary data back and forth. But by far the most common use case for it is to write data to these NFC tags like this one right here. The third method I haven't mentioned, and I saved this till the end because my guess is none of you will ever need it. I've got a demo that shows how it works, but again, it's a bit contrived. The method is named publish URI message. And whereas I can record a URI on a tag, which will automatically launch a browser on most devices, I can use publish URI message to programmatically publish a URI from a device so that I could hold 2 devices together and publish a URI message from one to the other. Now, one reason this is interesting, by the way, and this applies to URIs that you write to smart tags, not just to URIs that you're publishing from an active device. Most platforms allow apps to be associated with protocols. For example, virtually every platform will default to its own browser if asked to activate a URI that begins with HTTP:. One thing that is documented, but is not documented incredibly well, is that in Windows 8 and Windows Phone 8, there are lots of built-in applications that are registered as protocol handlers. So, for example, if you wanted to publish an in-depth message either from a device like this one or from a tag like this one that would launch Skype on a Windows 8 or Windows Phone device, this is all you have to do. This works because on a Windows Phone and on a Windows 8 device, the Skype app registers itself as a protocol handler for the Skype protocol. And there are others as well. There's actually an MSDN document that describes, if you do a search on Windows 8 URI associations or Windows 8 protocol handlers, you'll find a fairly complete list. The final thing, you can subscribe to URI messages as well by doing this. My guess is you will never need to do this. All mobile platforms automatically respond to an NFC URI message by attempting to launch the app that's associated with the protocol in the URI. But if for some reason you wanted to, in your code, know when a proximate device approaches you offering a URI, you could subscribe to those messages yourself. By the way, there is no API. In fact, it's not possible on a Windows 8 device or a Windows Phone 8 device to prevent the operating system from also responding to that by popping up a toast window saying to the user, do you want to launch this URI? So you can do this in addition to what the OS does, but you can't tell the OS not to do what it does. And with that, I hope your life is a little bit better than it was this morning. I changed your life just a little bit like I promised it would. Remember this URL right here? You can download these samples and some more that I didn't show. Go out and do some awesome things with NFC. Thank you.